As the first step of ANN-based data fusion, two registered images are decomposed into several blocks with size of m and n. Then, features of the corresponding blocks in the two original images are extracted, and the normalized feature vector incident to neural networks can be constructed. The features used here to evaluate the fusion effect are normally spatial frequency, visibility, and edge. The next step is to select some vector samples to train neural networks. An ANN is a universal function approximator that directly adapts to any nonlinear function defined by a representative set of training data. Once trained, the ANN model can remember a functional relationship and be used for further calculations. For these reasons, the ANN concept has been adopted to develop strongly nonlinear models for multiple sensors data fusion. Thomas et al. Discussed the optimal fusion method of TV and infrared images using artificial neural networks. After that, many neural network models have been proposed for image fusion such as BP, SOFIM, and ArtMap neural networks. BP algorithm has been mostly used. However, the convergence of BP networks is slow and the global minima of the error space may not be always achieved. As an unsupervised network, SOFIM network clusters input sample through competitive learning. But the number of output neurons should be set before constructing neural networks model. RBF neural network can approximate objective function at any precise level if enough hidden units are provided. The advantages of RBF network training include no iteration, few training parameters, high training speed, simply process and memory functions. Hong explored the way that using RBF neural networks combined with nearest neighbor clustering method to cluster, and membership weighting is used to fuse. Experiments show this method can obtain the better effect of cluster fusion with proper width parameter. Gale et al. Used adaptive resonance theory, ART, neural networks to form a new framework for self-organizing information fusion. The ArtMap neural network can act as a self-organizing expert system to derive hierarchical knowledge structures from inconsistent training data. ArtMap information fusion resolves apparent contradictions in input pixel labels by assigning output classes to levels in a knowledge hierarchy. Wang et al. Presented a feature-level image fusion method based on segmentation region and neural networks. The results indicated that this combined fusion scheme was more efficient than that of traditional methods. The ANN-based fusion method exploits the pattern recognition capabilities of artificial neural networks, and meanwhile, the learning capability of neural networks makes it feasible to customize the image fusion process. Many of applications indicated that the ANN-based fusion methods had more advantages than traditional statistical methods, especially when input multiple sensor data were incomplete or with much noises. It is often served as an efficient decision-level fusion tools for its self-learning characters, especially in land use/land cover classification. In addition, the multiple inputs minus multiple outputs framework make it to be a possible approach to fuse high-dimension data, such as long-term time series data or hyper-spectral data. Dempster-Shafer decision theory is considered a generalized Bayesian theory, used when the data contributing to the determination of the analysis of the images is subject to uncertainty. It allows distributing support for proposition not only to a proposition itself but also to the union of propositions that include it. Huadong Wu et al. Presented a system framework that manages information overlap and resolves conflicts, and the system provides generalizable architectural support that facilitates sensor fusion. Compared with Bayesian theory, the Dempster-Shafer theory of evidence feels closer to our human perception and reasoning processes. Its capability to assign uncertainty or ignorance to propositions is a powerful tool for dealing with a large range of problems that otherwise would seem intractable. The Dempster-Shafer theory of evidence has been applied on image fusion using spot/HRV image and Noah/over series. The results show unambiguously the major improvement brought by such a data fusion, and the performance of the proposed method. Boroshnik et al. Compared three frameworks for information fusion and view planning using different uncertainty calculi, probability theory, possibility theory and Dempster-Shafer theory of evidence. The results indicated that Dempster-Shafer decision theory-based sensor fusion method will achieve much higher performance improvement, and it provides estimates of imprecision and uncertainty of the information derived from different sources.